We'll be talking to you today about the OWASP Top 10 as relates to InterSystems IRIS application development. I'm Tim Leavitt. I'm the Development Manager in Application Services at InterSystems.
I'm Pravin Barton. I'm a developer in Tim's team, the Application Services Department.
I'm Huang. I'm a technical specialist in the Application Service team.
So today we'll talk about what the OWASP Top 10 is and isn't, and then we'll consider the individual items in that list as relates to application development on InterSystems IRIS. So coming out of this, you should have a better understanding of the security landscape, be able to avoid some common security pitfalls, especially working on IRIS, and maybe just generally think more like a hacker. So what's the OWASP Top 10? OWASP stands for the Open Web Application Security Project, and they really have a number of super valuable, useful resources for thinking about security, particularly in a web application setting, surprise. So the OWASP Top 10 is a standard awareness document. It's not really a definitive guide. It's just a consensus around what the most critical risks are in web application security. And because of that, it's a good first step for thinking about security. It's also updated periodically because these risks change over time as attackers start doing new things. And there's a version that just came out in late 2021. Before that, it was a 2017 version. So you may have seen this before, but not the updated version. And we will be talking, of course, about that 2021 version. So this list is not really exhaustive. It's not a list of everything that might possibly go wrong in one of your applications. The common weakness enumeration, or CWE, is that. It's also not a checklist for what you should do in your application. There are a few of those out there. One from OWASP is the Application Security Verification Standard. And it's not really accompanied by technical solutions because these vary by technology, but we are going to get into some of those for IRIS today. As a side note, there's also an OWASP API Top 10. If you're working largely or entirely with REST and SOAP APIs, say, that might be more relevant to you than this. And I talked about that in an earlier presentation on Tuesday. But this is really general web application focus. So if you're building applications on CSP or Zen or more modern approaches in IRIS, this is relevant for you. Some general themes that we'll see throughout these items today. First, use IRIS platform security features. Don't reinvent them or come up with your own clever things. It's never too early to think about security for your application, and it's least expensive to do so before you start writing code to build security into the design from the start. And it's probably not too late to think about security for your application, so you should do that now. And also, it's especially easy to fall into traps when you're trying to build generic things or frameworks for building your own applications. So that's somewhere that you really need to question assumptions. You know, once you've built something there, you've done it once, it just works, you don't think about it. And that's a good place to go back and question assumptions.
So now we're going to turn to a quick tour of each of the 10 categories. And for each of these categories, there's a couple of CWEs, the common weaknesses associated with it, and we're going to give examples. So the first one is failures in the access control policy. The access control policy in your system is what determines users' intended permissions. So if that's broken, risks can be disclosing information to people who shouldn't really have it, or even letting people kick off business processes that they shouldn't be able to do, like modifying or deleting data. A few of the weaknesses associated with this. The first one is the insertion of sensitive information into sent data. For this one, think about the error messages you're giving in your API endpoints or your pages. Does it include like a stack trace, a verbose detailed error message? And is that revealing something that really shouldn't be revealed to a user? The second one is improper authorization. So a common pattern here is like you have a page or an endpoint that references a specific entity by the ID in a URL query parameter. And you're getting that entity with like direct object access. Are you making sure that the user really should have access to perform this operation on that specific entity? If you're using SQL, it's easy to define this at the database level with row-level permissions. But if you're using direct object access and object script, those don't apply. So you need to make sure you're accounting for that in the application code itself. A third one here is cross-site request forgery. SSRF is a really common vulnerability. This occurs when a user is authenticated to your service with some web browser cookies, but then they browse to some malicious website. That website performs a cross-origin request. That request is authenticated by the browser cookies, and it accomplishes the attacker goals without even letting the user know what's happening. There are a lot of ways to mitigate this. One we'll draw your attention to in IRIS is setting the same site parameter on the cookies, session cookies. So this is in the IRIS web applications settings. You can set this to strict or lax. That's pretty much the default. But if you have an existing application that you're upgrading to IRIS, it'll probably stick with the none, which is the default before. A final one here is direct request or forced browsing. For this one, think about any business process that spans across multiple pages or API endpoints. Are you checking authorization just at the very entry point to this business process, or on each individual endpoint, each individual page?
All right, number 2, cryptographic failures. The most important thing to work with crypto is always use somebody else's no good implementation rather than inventing your own. And in the case of IRIS, this means use the $system.encryption methods. There are several CWEs fall under this category, and we will discuss a few of them here. So first one, CWE 319, clear text transmission of sensitive information. There is a private Apache web server shipped with IRIS, and by default, it's running over HTTP, not HTTPS. It's just for convenience, and it's probably fine for a local dev environment, but it's not good for network access or production. So you should think about securing it or disabling it, because even in your internal network, an attacker can sit in the middle of somewhere and packet sniffing your clear text password. And note that in another presentation on Tuesday, Andreas mentioned that we have work underway to remove the private Apache in the future. But for now, just think about securing it. Second one, CWE 331, insufficient entropy. For many crypto algorithms, the security relies on entropy or randomness. So if you want to use a secure, strong, pseudo-random number generator, you should use the one in $system.encryption. There is another one called $random object script method, but that one doesn't provide enough entropy. So third one, CWE 321, use of hard-coded cryptographic key. Some developers sometimes hard-code their key or secret in the program. It's convenient, but it also puts your system in danger because attacker can somehow get access to the source code and they can read your secret. And in the case of IRIS, this reminds me of the key management topic. So in IRIS, it has a functionality that you can generate a new strong key or manage your key using IRIS key management function, and you can use a username or password to protect the key, so to make it safe.
Next is a big one that you probably most likely heard of, and that's injection. So that's when an attacker's input runs as code somewhere it shouldn't, maybe on the server because they're injecting some SQL or some operating system command, or maybe on the client through some sort of cross-site scripting. So we'll look at a few of these in detail. In cross-site scripting, what you would typically see is an attacker's input either being included in a URL such that it's repeated back out in the page, unescaped, and then runs as, say, JavaScript in the page, which could steal cookies or make requests on the user's behalf. The other mode of this is stored cross-site scripting, where the attacker saves malicious code in some field into the database such that when a page reloads, that stored content is rendered back out as code and runs in the victim's browser. So the way to protect against this in a CSP setting would be to use the escape HTML and quote.js functions from %csp.page, depending on the context that you're in. So quote JS for getting a quoted JavaScript string that's safe, escape HTML for rendering possible unsafe user input directly in HTML. Next up is SQL injection, and I'd think of this most commonly when you're building and executing a dynamic SQL statement. So suppose that there's a filter in the URL, an optional URL parameter that the user could supply some value, and if they do, then you'll filter the query results based on that. The wrong thing to do is to concatenate the user's input directly in the query. We don't really have the classic, there's a classic XKCD where it's like Bobby Tables, name is Robert, close single quote, close paren, semicolon, drop table students. We don't really have that, or we don't have that vulnerability in our dynamic SQL because you can only execute one statement at a time. But you could say where name equals 0, union all, select whatever else from whatever table I want, and that would just execute with the current user's SQL permissions. And so there's real possibility for data exposure there, and that's the real main risk for SQL injection in IRIS. So what the safe thing to do here is there's this variadic argument syntax that works really well here, where you can say build an array of arguments and pass that into your SQL statement, or pass that in when you execute the SQL statement, and in parallel dynamically build the SQL statement and the array of arguments to use with it. And that question mark substitution syntax is safe. Also note in the response, as we're rendering out an unordered list in HTML, we are escaping the content that we get back from that query because that prevents stored cross-site scripting attacks. Here's a tricky one, external control of a file name or path. I think I got this right from a developer community post that someone was looking at doing the other day, where you just want to say, I want to provide access to some file on the server. So you put a file path in the URL, you open that as a file character stream, and output it to the device. Well, what if that's like your iris.dat or some other file that has sensitive information? This is really not a safe thing to do, and there are a whole bunch of ways to get it wrong. If you really must do that, there's more detail than I want to go into here in terms of how to do that correctly. What you need to worry about there is also possibly path traversal, where your file name says go back up a couple directories and then navigate back down to get something outside of where you expect. So there are ways to mitigate against that. Next, we'll look at OS command injection. A couple years ago, we released new $ZF functions that make this better. It used to be, so say we're issuing a command to git clone some repository. If we're using $ZF -1 and concatenating user input in, that could be git clone repo name and && format C or whatever. And that we're executing whatever commands the attacker, or the user attacker, happens to provide. So the new way to do that would be using $ZF -100, which is just better in a lot of ways. And it's kind of a similar approach, building up an array of arguments that are safely quoted, unless you say use the no quote parameter, which you just shouldn't do because that defeats the whole point. And there are some options in there for managing standard in and out and error and whether or not it executes as a shell. So read the documentation on that. If you're using $ZF -1 or -2, look to replace that with the new secure equivalent. So that's injection, a lot of topics there. Hopefully that it is relevant to things that you've seen before.
All right, our fourth category here is insecure design, and this is a very broad topic. The basic takeaway is to think about security much earlier in the software development lifecycle. So this is at the stage where you're still designing the system before you start implementing anything. So what can you think about at this early stage? One big set of guidelines is threat modeling. That means you think about what an attacker would want out of your system, how they could exploit your system, and how you can secure your system against their possible exploits. We've linked here a threat modeling manifesto. That's a very good broad guideline about how to build a culture of threat modeling in your organization. And another thing you can think about here is, again, consider using IRIS platform security features rather than rolling your own. If you have some requirements, think about how IRIS can fulfill them rather than your own custom code.
Okay. So number 5, security misconfiguration. Did we mention that you should use IRIS platform security feature rather than circumventing them for the sake of simplicity or inventing your own? So there are many technology-specific CWEs fall under this category, but there are also broader concept, general concept fall under this category. So we will discuss a few of them here. Let's look at the first 2. Next slide. So missing security hardening and default accounts are enabled. During IRIS installation, there is a step asking you to choose the initial security settings. And by default, minimal is selected. I know some people just click next to speed up the installation, but yeah, that's convenient, but that really put your system in danger because everything is unauthenticated. So the suggested way, the recommended way is use the lockdown security setting, the most secure one. But or at least you should use the normal. Just don't use the minimal settings. And there are default accounts in IRIS. They are underscore system, admin, super user. During installation, it asks you for passwords. Do you provide a secure, strong password here, or do you use some well-known passwords such as capital SYS or 12345? This is a question to think about when you do the installation. And note again, in updating security presentation in Tuesday, Andreas mentioned we have work on the way. We will remove the minimal security setting, and we will remove the default accounts in the future. And so, yeah, the third one, unnecessary features are enabled or installed. This is a question to ask yourself. If you have an API or service that is not in use, do you disable it or do you leave it enabled? Use of new security features on upgrade. Once you upgrade your IRIS instance, do you actually make use of the new security features, such as the same-side cookie settings, which can protect you against SSRF attack a bit? So on this number 5 topic, there are 2 helpful resources in our documentation. There are Titan Security for an Instance and Security Advisor.
I know those links are kind of hard to click, but the PowerPoint should be in the event app if you want to pull it down and look at all of these later. Next topic is vulnerable and outdated components. This is a good reminder to stay up to date on IRIS upgrades so that IRIS doesn't become the vulnerable and outdated component in your system. We also had some relevant content on this in updates in security. And this really seems like it's been a huge topic over the past year. It felt like twice a week for a couple weeks there was a new Log4j vulnerability, and we kept having to patch those things. And it's something that we're thinking about more at InterSystems, and it's just generally good to think about. And I would recommend, within IRIS, that's kind of our problem, but within your own things that you're building, I would recommend using industry standard tools, for example, in a JavaScript project where you have 10,000 dependencies, to figure out what they are and if there are vulnerabilities and manage those and keep an eye on them over time.
All right, our next category is going to be failures with the parts of your system that identify or authenticate users. Again, a big theme here is going to be using the IRIS platform security features, or if you are extending them, use our documented APIs with delegated authentication, the Z-authenticate routine, that's fine. If you use those, you get things like protection against session fixation attacks. You get a way to force users to have a strong password. You get a secure implementation or a way to implement multi-factor authentication. And for passwords, you know they're salted, they're hashed, they're not stored in plain text in the database. If you're rolling your own security features, just writing your own custom code, you have to think about each of those things. Also under this category is going to be issues with TLS certificates and certificate verification. So IRIS supports TLS. You can go into the SMP and create a TLS configuration, but you have to make sure that your configuration is set up to be secure. So one weakness here is improper following of a certificate's chain of trust. This has to do with, like, say you're checking a certificate, but you don't know that the certificate authority that issued it has actually revoked that certificate because it got stolen somehow. One new IRIS feature that helps with this is support for OCSP stapling as of IRIS 2021.2. So here's that page for creating a TLS configuration. I know TLS can be a little intimidating. The main takeaway I want to have you get here is to talk to your communication partners and also to your security admins. And that'll help you figure out what the security requirements actually are and where to get the certificate files. So if your IRIS instance is authenticating somebody else, you need to make sure that somebody else is who they say they are. They need a certificate and they need a key file. And you need the root CA certificate, the certificate for the authority that verifies their certificate. If it's the other way around, where your instance is being authenticated by somebody else, then you need the certificate, you need the key file, and they need the CA certificate. So this is an example of the first scenario where IRIS is like a client, it's a client configuration. You'll notice there's a server certificate verification, and that's turned on. You have selected require, and we've put in a root certificate for the CA. And at the very bottom there's that setting for OCSP stapling. If the other server supports that, I definitely recommend turning that on.
So number 8, software data integrity failures. This is largely related to the third-party component or software you are putting in, either at runtime or in your CI/CD project. So this is an area where there isn't really a lot of IRIS specifics to talk about, but we will still show some CWE, highlighted CWEs here. So the first one, A30, inclusion of web functionality from an untrusted source. This is a question to ask yourself, in your system, in your application, who do you trust? Do you trust a data source because it comes from your internal network? Or do you trust a data source because it comes from some external but famous company, such as InterSystems? Well, the best practice is trust nobody. The no trust rule is very important in the security world. And then the second one, 915, improperly control modification of dynamically determined object attributes. That was long. So in general, this would remind me of the JavaScript prototype pollution attack. But in the case of IRIS, this is something important to think about when you are writing generic code or design of your framework, such as, for example, when you are assigning values from %request to an object using $property, do you actually do any validation, or do you just assign the value? So there is another documentation, inventory scan capability in IRIS, so feel free to check it out.
So the inventory scan would really be for ensuring the integrity of your own software and comparing, like, has anybody messed with the classes or something like that. Next up, we have security logging and monitoring failures. So suppose you're actually under attack. How do you know? Is anybody actually watching? So for this, really, the IRIS audit database is key. It'll track logins, logouts, login failures, protect events where, optionally, where someone's trying to access something they don't have privileges to at the database level. You can also define your own event types within the audit database for security relevant events in your own application, if it's like a big transaction or something like that. And one thing, of course, to be careful here is making sure that as you put things into the audit database, you're not putting sensitive data that, if the audit database or any downstream systems were compromised, would expose stuff that shouldn't be exposed about users of your application. So things like passwords, for example, should not end up in the audit database or logging in general. But we do want to be able to identify if someone is attacking, what they're doing, where they're coming from. One new IRIS feature that's really helpful for this is structured logging, and that allows you to take a combination of the audit database and the messages log file with system-level events and notifications, and put all of that together and send it to a centralized monitoring system. I haven't personally gotten to play with that yet, but I really want to, and I'm hoping to do that sometime this year. Really, this is, I think that's the right way to get your monitoring in place, having all the systems going to one place that can detect unusual events coming from anywhere.
All right, number 10, SSRF, or server-side request forgery. This is an interesting new item in the top 10. It is there because it was the #1 item from the top 10 community survey, not just because it's one of my favorite. And it's also mapped to CWE 918, which is also called SSRF, or server-side request forgery. And what this vulnerability looks like in IRIS generally is, think about a case that you take URL as user input and you forget to validate the URL. Then you might parse it a bit, use %net.url parser, and then you make HTTP request using %net.http request. So now the problem arises. The URL can be controlled by an attacker, which means the attacker can send their own URL, port, schemas, destination, whatever that you might not expect. And then the HTTP request is made. This is bad because the request is not made by the attacker or not with the attacker's level of access to your network. It's actually made by the server or by your server and by your server's level of access to your network. So it can bypass all the firewalls or network protections you have and opens a door to your internal network.
So that was our quick tour of all of the OWASP top 10 categories. Just to reiterate some of the key takeaways we hope you got away from this. So the first one is that all of the general web application security concepts, all of the risks that you might be familiar with from other platforms also are going to apply in IRIS. But they each have their own mitigation steps that are specific to IRIS and ObjectScript. Second, we'll repeat for maybe the 6th time, using built-in IRIS security features. Rather than trying to invent your own from scratch, that's always a good idea. And finally, it's never too early to start thinking about application security, and it's probably not too late, so why not now? Some next steps, there were some sessions that happened earlier that were very relevant, very helpful. You can hopefully find the recordings of these. The updates and security session from Andreas and Tim's modern full stack app development session. And there's also the OWASP resources with all of this information at owasp.org. Here's some relevant links. Again, go into the app. You'll be able to click these if you can access the presentation. And finally, how do you contact us if you have questions about security? So general questions about InterSystems, anything related to security, a good person to reach out to is globaltrust@intersystems.com, and that'll go to an internal team. For really specific questions about the security of an individual InterSystems product, or more than one, you can go to psirt, P-S-I-R-T, @intersystems.com. And finally, you can connect with all of us, either through the email, developer community, or LinkedIn.
Thank you. Are there any questions?